Welcome back to All This Math. This is Professor Parker, and we about to evaluate a function right now. All right, so let's take a look at what we're working with. We have h of x, so the name of the function is h, right? That's just the name of the function, all right? This does not mean h times x because we're using function notation. So in this situation, these parentheses do not represent multiplication. They don't. We're dealing with a function. So this is the function h, and this tells you that you can put different values of x into the function. All right, so this is h of x, or it's h, and it's going to have different x values. That's what that means. H of x is equal to 6 divided by 5x squared minus 3x. That's the original function, right? Now, what you're asked to do is find h of x plus 1. So that means that we're essentially replacing the x with an x plus 1, right? So that means inside this function, on this side of the equal sign, wherever you see an x at, you got to replace it with this binomial x plus 1. That's what that means. Wherever you see an x, so right here and right here, this x got to go and this x got to go. It's going to get replaced by x plus 1. All right, so look. So this x and this x are going to get replaced by x plus 1. That's what's going to happen. All right. That's how we evaluate functions. So let me show you what it's going to look like. Now, the only thing that changes is those x's. This 6 don't change. This fraction bar don't change. This 5 don't change. This exponent 2 don't change. This minus sign don't change. This 3 don't change. The only thing that changes, I can't emphasize this enough. The only thing that changes is this x and this x. And that's going to change into an x plus 1. And that's going to change into an x plus 1. Now I'm about to show you what it's going to look like. So I'm going to write my 6. That's my numerator. Then I write my 5. Then instead of the x, instead of writing the x next to the 5, I'm going to write x plus 1 in parentheses. Whenever we replace or substitute, you put that value in parentheses. All right? So next to the 5, I'm going to put x plus 1. Here we go. So the x plus 1. So look what happened. This x got replaced with x plus 1. The exponent 2 is still there. Boom. The minus sign, still there. The 3, still there. Now wait, we're not writing this x. We're not writing this x. We're replacing it with x plus 1. And now we're ready to get to work. So now we just had to replace this x and this x with the x plus 1 and the x plus 1. Now you got to simplify. It's nothing to simplify on top. It's just a 6. It's just a random 6. You can't do nothing with that 6. Just leave it there. But in the denominator, there's a whole lot we could do. Like, for example, we can simplify this x plus 1 squared. Now, one thing I'm going to tell you, this does not equal x squared plus 1 squared. It does not equal x squared plus 1 squared. You can't do that. That defies mathematical rules. You can't do that. This really means x plus 1 times x plus 1. So think about the FOIL method that you might have learned, either in an Algebra 1 class or Algebra 2 class. FOIL method, x plus 1 times x plus 1, right? This how it would look. X plus 1, boom, times x plus 1, boom. FOIL method, the F stands for the first terms, x times x. That's x squared. The O stands for the outer terms, the x and the 1. So that's plus x. The I stands for the inner terms, the 1 and the x. That's 1 times x. So that's another plus x. The L stands for the last terms, the 1 and the 1. So that's 1 times 1. 1 times 1 is 1. It's not 2. Don't make that careless mistake and write 2. It's just plus 1. Then you combine like terms, the x and the x. So you left with x squared plus 2x plus 1. So this is equal to that. This is equal to that, right? When you expand it, we got to expand it, right? So we can then try to combine like terms. All right? Now, this is also what we call a special product. There's like an algorithm that we can follow, basically, which is going to enable us to simplify this or expand it without multiplying it out using the FOIL method. Basically, you take the first term and you square it. That's how we get x squared. You take the last term and you square that. You get 1. That's how you get the last term. Now, how do you get the middle term? This is how you get the middle term, because it's going to be a trinomial. That's something you got to memorize. Whenever you see a binomial squared, it's going to be equal to some trinomial, right? So the way you get the middle term is you do x times 1, you do the first term times the second term, and then you take that product and you double it. Take that product and you double it. So x times 1 is x, then you double that, that gives you 2x. That's where the 2x came from. So you could have did FOIL like that, or you could have just memorized that special product formula, right? And then just know it's going to be x squared plus 2x plus 1. You know what I mean? So now let's do this. Let's rewrite this. 6 on top, 5 still on the outside. X squared plus 2x plus 1. Boom. Now over here, matter of fact, I'm going to keep that for now. 3 times quantity x plus 1, right? So now we got to distribute. Well, actually, yeah, we got to distribute in a denominator. We got to distribute the 5. So this 5 gets distributed to everything. This 5 gets distributed to everything. This 5 gets distributed to everything. So 5 gets distributed to x squared. So that's 5x squared. This 5 gets distributed to the 2x. So that's 5 times 2x, which is 10x. The 5 gets distributed to the 1. 5 times 1 is 5. Now, the negative 3. The negative 3 gets distributed to x. Negative 3x is minus 3x. Negative 3 times 1 is minus 3. All right? So now everything is multiplied out. That's multiplied out. And now we're able to combine like terms. So you look for like terms. 5x squared does not have a like term. 10x has a like term, though. Let's label our like terms. This is the fun part, combining like terms. 10x, negative 3x. 5 and negative 3. They go together. The 10x and the negative 3x go together, and the 5 and the negative 3 go together. Now we about to be done. We about to be done. So we got equals 6, and then we got 5x squared. And then we have 10x minus 3x, and I'm gonna put that next because that's x to the first power. When we write this, we should write our terms in descending order, all right, according to the exponents. Descending order according to the exponents. Biggest exponent first, next biggest exponent second, next biggest exponent third, and so on. So 10x minus 3x is going to be 7x, so that's plus 7x. And then the 5 minus 3, the 5 and the minus 3 go together, that becomes positive 2. This is our final answer. 6 over 5x squared plus 7x plus 2. So h of x plus 1 is equal to 6 divided by 5x squared plus 7x plus 2. So look at how it differs. So 6 over 5x squared minus 3x was the original function, or what we might call the parent function. But then h of x plus 1 is going to be 6 over 5x squared plus 7x plus 2. You know? All right. And this is how we evaluate functions. All right. So understand what the original function is, and then understand what you're being asked to input into the function. So wherever you see an x, you replace it with this. So here and here, you replace it with x plus 1. Everything else stays the same. The 5 was still there. The minus sign was still there. The exponent 2 was still there. The 3 was still there. Then you go to work. You start simplifying. You distribute. Use order of operations. You might have to use the FOIL method like I did up here. Or if you memorize, you know, the special product, that x plus 1 squared is a special product. All right? So, all right, that's that. So now I showed you how to do it. Now go get some practice because you really learn by practicing. You got to practice on your own. All right? So go get some practice, and I'm going to catch up with you on the next video. All right? Peace.